It is hiding in plain sight. Inside one of the most famous star systems in our galaxy, a giant planet has been circling its sun for 23 million years, while telescopes look straight past it. The star throws out a thick, bright cloud of dusty debris, and the planet wears that dust like a blanket, so all this time it stayed completely invisible. Until the James Webb Space Telescope finally caught it, and scientists suddenly realized the system they thought they knew had a whole extra world hiding inside. If you want to be one of the first people on Earth to watch another world get discovered, then make sure you are subscribed. We bring you real space science in plain words, with no made-up stories and no wild guesses. Hit subscribe, and you will be right here the next time a hidden planet shows its face. Let us start at the beginning, because the story of how we see other worlds is one of the most surprising tales in modern science. A planet that orbits a star outside our solar system is called an exoplanet. The word simply means a planet beyond our own family of worlds. Our sun has 8 known planets circling it, and scientists now believe almost every star in the night sky has planets of its own. That means the galaxy is packed with worlds, possibly billions of them. To make sense of the distances in this story, we need one simple idea. A light year is the distance light travels in 1 year, and light is the fastest thing there is, moving about 300,000 kilometers every second. In 1 year, a beam of light crosses roughly 9.5 trillion kilometers. So when we say a planet is 12 light years away, we mean its light takes 12 full years to reach our eyes. It is close compared to the rest of the galaxy, but staggeringly far for anything built by humans. For a very long time, nobody knew if planets existed around other stars at all. People guessed they did, because why would our sun be special? But guessing is not knowing. It was not until 1995 that 2 astronomers, Michel Mayor and Didier Queloz, found the first real planet around a sun-like star. They spotted it by watching the star wobble, pulled back and forth by the gravity of a hidden planet beside it. Neither man was hunting for a planet, and in 2019 they won the Nobel Prize for what they found anyway. Since then, the hunt has exploded. In 2009, NASA launched a space telescope named Kepler, and it changed everything. Kepler stared at one patch of sky and watched for tiny dips in starlight, moments when a planet passed in front of its star and blocked a sliver of light. That method, called the transit method, found thousands of worlds. Today, scientists have confirmed more than 6,000 exoplanets, and new ones are added all the time. But here is the tricky part, and it is easy to miss. Almost all of those 6,000 worlds have never actually been seen. Astronomers found them by watching the star, not the planet. They saw a tiny dip in the star's light, or they caught the star wobbling from the planet's pull. The planet itself stayed invisible, just a shadow or a wiggle in the data. No picture, no dot of light, nothing you could point at and say, there it is. That is real science, but it is a little like knowing someone is in a room because you hear their footsteps without ever seeing their face. Seeing a planet directly, actually catching its light and making a picture of it, is one of the hardest things a telescope can do. Here is why. A star is a giant ball of burning gas, and it is unimaginably bright. A planet makes almost no light of its own at all. It only reflects a little starlight and glows faintly with leftover heat from its birth. A star can be billions of times brighter than the planets around it. The planet is like a tiny candle sitting right next to a blazing bonfire. Imagine trying to photograph a firefly sitting 1 inch away from a searchlight. The searchlight washes out everything around it, and the firefly vanishes in the glare. That is the problem astronomers faced for decades. Even the biggest telescopes on Earth could not pick a faint planet out of a brilliant star's glow. It would be like trying to see a small coin on a bright beach from a mile away with the sun shining straight into your eyes. For years, that coin stayed invisible. Have you ever stopped to think about how strange it is that we cannot just look at a distant planet and see it the way we see the moon? Most people assume space telescopes photograph everything, but the truth is far harder than that. If the glare problem surprised you, drop the word glare in the comments and like this video so more curious people can find it. The best discoveries are still coming. Then came the James Webb Space Telescope, the most powerful space observatory ever built. It launched on December 25, 2021, folded up like origami inside a rocket, and then unfolded itself in space over the following weeks. Its main mirror is 6.5 meters wide, made of 18 gold-covered pieces that work as one giant eye. Behind the mirror hangs a sun shield about the size of a tennis court, and Webb now floats 1.5 million kilometers from Earth, far beyond the moon, at a quiet spot called Lagrange Point 2. Being in space is only half the trick. Webb also has to be freezing cold, because the telescope itself gives off heat, and that heat would blind it to the faint warmth of distant planets. The sun shield keeps the mirror at below minus 220 degrees Celsius, colder than the deepest shadows of space. At that temperature, the telescope's own glow nearly disappears, and only the planet's light remains. It is like trying to hear a whisper inside a silent room. So Webb built itself the quietest room in the universe. Why does Webb study infrared light, the kind we feel as heat? Because planets glow brightest in that range. A young planet is still hot from its birth, and it shines in infrared like a warm coal in a dark fireplace, even when it is invisible in normal light. Older, colder planets glow too, just more faintly. Webb was built to catch exactly that faint warmth, and it carries special tools called coronagraphs, which are tiny eclipses it can make on command. Here is how a coronagraph works in the simplest terms. You have probably blocked the sun with your thumb, and suddenly you could see things around it more clearly. A coronagraph does that same trick in space. It places a small dark mask in the middle of the image, blocking out the star's blinding light. With the star hidden, the dim planets around it finally step out of the glare, just like the moon's shadow reveals the sun's outer glow during a total solar eclipse. A simple idea that took engineers decades to make perfect. The first true pictures of exoplanets came in 2008, long before Webb. A Canadian astronomer named Christian Marois and his team pointed a telescope at a star called HR 8799, about 130 light-years away, and captured 4 giant planets in a single image. That same year, another team photographed a planet around the star Beta Pictoris. Those were the first times humans ever looked at actual dots of light that were other worlds, not shadows on a graph. History was made with a few blurry smudges. But those early pictures were only possible because the planets were enormous, several times bigger than Jupiter, and young enough to glow brightly. For years, the rules seemed set in stone. Direct imaging only worked for monster worlds, and anything smaller stayed hidden in the glare. Then Webb arrived, and it started breaking that rule, one discovery after another. And this is where the story gets strange, because Webb keeps finding worlds that look nothing like what scientists predicted. Here's the part people remember most. Cold planets are the hardest of all to see because they glow so faintly that their light is nearly nothing next to the star. Hot planets shine like embers, but cold planets are more like dying coals, barely warm to the touch of a telescope. For a long time, astronomers simply accepted that cold worlds were out of reach. Then Webb proved them wrong, and the first proof had a strange name: Epsilon Indi AB. Take the planet Epsilon Indi AB, which sits just 12 light-years from Earth. 12 light-years sounds far, but in space terms it is our next-door neighbor, one of the closest known planets of its kind. Astronomers already knew this world existed, and they had a clear picture of what it should look like. The model said it should be a fairly simple giant planet, a cold relative of Jupiter with a predictable sky. All they needed was a closer look, and in July 2023, Webb gave them one. Webb pointed its mid-infrared instrument, called MIRI, at the star, and a coronagraph blocked the star's light. There, in the dark, was the planet, glowing like a small ember. It turned out to be one of the coldest exoplanets ever directly imaged, with a temperature around 275 Kelvin. In everyday terms, that is about 2 degrees Celsius, roughly the temperature of a mild spring day. An entire giant planet warm enough for a light jacket, and nothing like the red-hot worlds we had pictured before. And it is huge. The latest measurements put its mass at about 7.5 times that of Jupiter, yet its width is about the same as Jupiter's. Imagine squeezing 7 or 8 Jupiters into one ball of the same size, and you start to get the picture. It orbits about 4 times farther from its star than Jupiter orbits our sun, so a single year on this world is extremely long. It is a cold, heavy giant drifting slowly through the dark, and it is rewriting what we thought cold planets look like. But here's the surprise that shook the models. When scientists studied the light from this planet, they expected a strong signal from ammonia gas in its air. Ammonia shows up in the atmospheres of cold, giant planets, and every standard model said the signal should be deep and clear. Instead, the signal was almost missing, far too weak to explain. The models failed, and scientists had to admit that something was hiding in that sky. Confused scientists are often the ones who make the best discoveries. The best explanation they found is strangely beautiful. Epsilon Indi AB may be covered in thick clouds of water ice. Not rain and not snow, but actual clouds made of frozen water floating high in the planet's atmosphere. Those ice clouds act like a curtain, muffling the ammonia signal below and making the whole planet look dimmer than expected. Nobody had ever seen a clear case like this on a directly imaged planet before. A giant world with ice clouds, drifting 12 light-years away like something out of a dream. That finding matters for a simple reason. If the models missed water ice clouds on this planet, they might be missing them on many planets. Astronomers could be reading the wrong story on other worlds, because clouds are hiding the truth beneath them. This is exactly what scientists mean when they say Webb is teaching us to study solar system twins. If we were aliens looking back at our own sun from far away, Webb would be the first telescope able to study our Jupiter in real detail. That is how close this field has come. What do you think clouds of frozen water would look like if you stood on a cold giant world? Would they glitter like ice on a frozen lake, or hang low and gray like winter fog on Earth? Take a guess in the comments. And then subscribe, because the next world we are about to visit is even stranger. These are real places, and we are only beginning to see them. Now let us move to a star called 14 Hercules, 60 light-years away, which hosts one of the strangest worlds ever photographed. This star is almost a twin of our Sun, similar in age and temperature. Around it circle two giant planets, and scientists thought they had a decent idea of how those planets moved. Then Webb took a picture in 2025, and the researchers used words like abnormal, chaotic, and strange to describe what they saw. Once you see it, you will understand every one of those words. The planet Webb imaged, called 14 Hercules c, weighs about 7 times as much as Jupiter, but the shocking detail is its temperature. It is one of the coldest exoplanets ever directly imaged, around -3 degrees Celsius, or about 26 degrees Fahrenheit. That is colder than the inside of a kitchen freezer. Until Webb, nearly every imaged planet was scorching hot, hundreds or even thousands of degrees, because hot planets glow brightly enough to see. Finding a world as cold as frozen food was a brand new kind of discovery. But the temperature is not the strangest part. The strangest part is the orbit. In our solar system, all 8 planets circle the Sun on nearly the same flat plane, like runners on the same track. Not here. The 2 planets around 14 Hercules cross each other's paths like an X, with the star at the center. Their orbital planes are tilted toward each other by about 40 degrees. It is the very first time scientists have ever photographed an exoplanet living in such a broken, tilted system, and nobody can fully explain how it happened. Here is the leading theory, and it sounds like something from a disaster movie. Scientists believe a third giant planet once lived in this system, and something violently threw it out into deep space. When a heavy object gets ejected from a young solar system, its gravity drags the other planets along, tilting their orbits like a tablecloth yanked at a dinner party. What we are seeing now may be the crime scene of a planetary battle that happened billions of years ago. Researchers have even called it a planetary crime scene in their papers. Now here is the part that should give us all a chill. Our own solar system went through something similar in its early days. Jupiter and Saturn threw asteroids around, rearranged the neighborhood, and reshaped everything. The history of planets is not peaceful. It is a story of giant bodies shoving each other, while small worlds like Earth simply had to survive the chaos. Looking at 14 Hercules c is like finding a mirror of our own violent past, and a reminder of how easily a home can be broken. What would have happened to Earth if a giant world from our own past had been thrown out of the solar system? Would our world even exist, or would we have been dragged into some tilted orbit long before life began? That is a real question scientists ask, and your guess is as good as theirs. Tell us what you think in the comments. And if these strange worlds are making you curious, hit subscribe so you do not miss the next one. We are just getting to the strangest part. Now we come to the discovery that truly rewrote the rules, a world with the plain name TWA7b. The star TWA7, also called CE Antliae, is young, only a few million years old, and it spins a disk of leftover rock and dust, the raw material that builds planets. Previous pictures of this disk showed 3 visible rings, and young stars like this one are where astronomers hope to catch planets being born. In June 2025, Webb found a bright spot inside that disk where no planet was supposed to be. The bright spot turned out to be a real planet, and its size broke every expectation. TWA7b has about 30% of Jupiter's mass, which means it weighs roughly 100 times as much as Earth, and it is similar in size to Saturn. That still sounds enormous, but here is the kicker. It is 10 times lighter than any exoplanet ever directly imaged before. For the very first time, scientists photographed a planet that begins to resemble the worlds we live among, not just giant monsters beyond imagination. Why does that matter so much? Because the old rule said direct imaging could only catch huge, bright, young planets. Smaller worlds are dimmer and they vanish next to their stars. If Webb can catch a Saturn-sized world like this, it might catch even smaller ones. The team behind the discovery hopes to one day image planets with only 10% of Jupiter's mass. That is getting close to a whole class of worlds we have only dreamed of seeing, and each step down that ladder is a step toward imaging a planet like Earth. The discovery was published in the journal Nature on June 25, 2025, by a team led by scientists in France. They used a specially built coronagraph attached to Webb's MIRI instrument, developed in France and England. It works like a tiny artificial eclipse, blocking the star's glare so the faint planet can shine through. Computer simulations confirmed that a planet of exactly this size would carve a thin ring and a gap in the dusty disk, precisely matching what Webb saw. The math, the image, and the models all agreed at once. Each of these discoveries was a surprise on its own, but the biggest one came last, and it happened almost by accident. Keep that in mind, because it changes how you think about everything else. The scientists were not even hunting for a new planet when they found the world that made headlines in 2026. They were studying a system named Beta Pictoris, one of the most watched star systems in the entire sky, and a hidden giant was about to give itself away. Beta Pictoris sits 63 light-years from Earth, and it is young, only about 23 million years old. In astronomical terms, that is a baby. Our own solar system is about 4.5 billion years old, roughly 200 times older than this star. Around Beta Pictoris spins a huge, bright disk of dust and debris, the leftovers of planet building. That disk is famous. It is one of the brightest debris disks known, and for decades it has been one of the best places in the sky to watch planets being born. Astronomers already knew two giant planets lived there, called Beta Pictoris b and Beta Pictoris c. Planet B was one of the very first exoplanets ever directly imaged, back in 2008. The system was so thoroughly studied that scientists believed they knew its entire family, but there were clues that something else was hiding. The dust disk has a strange, sharply defined inner edge, and some researchers had quietly predicted that a third planet might be carving it. They just could not prove it because the disk acts like fog. Imagine driving at night through thick fog. Your headlights hit the mist, and the road ahead becomes a white wall. Now imagine trying to spot a single weak streetlight far behind that wall. That is what the debris disk did to Beta Pictoris. The dust scatters the star's light and smears it across the image, hiding anything behind it. A planet sitting inside that fog was effectively invisible to the old methods. For years, it stayed right there, hidden by the brightest curtain in the local galaxy. In 2026, a team led by a researcher named Aidan Gibbs at the University of California, San Diego, was using Webb to study the atmosphere of Beta Pictoris b. They were not looking for a new planet at all, but in the data, they saw a pattern of dark lines spread out like a barcode that belonged to carbon monoxide gas. That barcode is the unmistakable fingerprint of a giant planet atmosphere. A third planet, now called Beta Pictoris d, had been sitting right there in the data all along, hidden inside the fog. Here is what makes this so clever, and it is the part people remember most. Normally, finding a planet means taking a picture of a dot of light, but Webb did something different this time. It split the incoming light into a rainbow and studied the dark lines in that rainbow. Different gases leave different patterns of lines, like fingerprints, and every gas has its own. Carbon monoxide leaves a specific pattern, and when that pattern appeared where dust should have given a smooth signal, the team knew a planet had to be there. A world found by its fingerprint, not its photograph. So, what is this hidden world like? Beta Pictoris d is a giant, at least 2 times the mass of Jupiter, and it orbits about 30 astronomical units from its star. 1 astronomical unit is the distance from Earth to the Sun, so this planet is roughly 30 times farther from its star than we are. To picture that, think of Neptune, the most distant planet in our own solar system. Beta Pictoris d lives at about Neptune's distance, and it holds the widest orbit of the 3 known planets in its system. Follow-up observations with Webb's MIRI instrument found water vapor and methane in its air, sealing the case. A second separate team using different telescopes confirmed the planet on their own. And because the spectrum reveals motion as well as chemistry, scientists could measure how fast the planet moves and prove it truly circles the star. In one stroke, Webb found a planet nobody expected and started reading its atmosphere at the same time. That kind of double win has never happened this way before. This discovery does more than add one more planet to the list. It adds a whole new weapon to the search. Until now, the best way to find planets directly was to block the star and look for a dot of light. But if a planet hides inside a bright, dusty fog, a photograph will never reveal it. The fingerprint method ignores the dust completely. It hunts only for the narrow chemical marks that belong to a planet's air, and dust cannot fake those marks. Worlds hiding in dusty systems, places we thought were hopeless, are suddenly findable. How many hidden worlds do you think are waiting inside dusty systems like this one, invisible to every picture we have ever taken? Take a guess in the comments and see how close you come when the next discovery drops. If you want to be part of that moment, subscribe and turn on notifications, because this channel is where the hidden planets show up first. The countdown to the next one has already started. The same telescope is rewriting what we know about another famous family of worlds, HR 8799, the system where 4 planets were first imaged back in 2008. In March 2025, Webb made its first direct detection of carbon dioxide gas on planets outside our solar system, right in that system. Finding carbon dioxide on all 4 giants tells astronomers something deep about how planets are born. It is a clue that these worlds formed slowly, growing solid cores that then pulled in gas, the same way we think Jupiter and Saturn formed in our own youth. Scientists once wondered if giant planets form in 2 very different ways. One way is slow and steady, a solid ball growing in the disk until it is heavy enough to pull in gas. The other way is fast and violent, a whole cloud collapsing at once like a failed star. The carbon dioxide finding points strongly to the slow, steady growth. That matters because the way a planet forms shapes everything about it, its size, its air, its whole life story. And it shapes the fate of smaller worlds in the same system, because giants act like bowling balls, able to protect a world like ours or destroy it. The same observations also caught the innermost planet of the HR 8799 family in a wavelength that had never been seen in before, and another world called 51 Eridani b, about 96 light-years away, showed up in the same survey. Every new wavelength Webb opens reveals planets that were invisible at every other wavelength. It is like turning on a new kind of light in a dark room and suddenly noticing furniture that was there the whole time. The room was never empty, and now we are finally turning on all the lights. Now here is where the story turns from the past to the present, because this is not a finished chapter. Right now, as you listen to this, Webb is still out there, 1.5 million kilometers away, collecting new light from dozens of star systems. Teams around the world are digging through fresh data every week, looking for barcode fingerprints that nobody has noticed yet. Every few months, another paper drops and another hidden world steps into the light. The pace is not slowing down, and the surprises keep getting bigger. And Webb is not even the last word. A new telescope called the Nancy Grace Roman Space Telescope is set to launch within the next year or two, and it carries the most powerful coronagraph ever flown in space. It will block starlight even more cleanly than Webb can, opening the door to imaging planets that are truly small and truly cool, the kind of worlds where we might one day look for signs of life. Scientists are already planning which nearby stars to point it at first. If Webb opened the door, Roman may throw it wide open. Sit with these numbers for a moment, because they are worth hearing slowly. Scientists have confirmed more than 6,000 exoplanets. Of those, only a tiny fraction, fewer than 100, have ever been directly imaged by any telescope in human history. That means every picture of another world ever taken could almost fit in a single classroom slideshow. And a large share of those rare portraits were captured in just the last few years by one machine. Every direct image that exists today is rarer than gold, and each one is a tiny portrait of another world. And here's the thought that keeps astronomers awake at night. Somewhere in that fog of dust and light, right now, there may be a rocky planet almost exactly like Earth, sitting undiscovered in a system we have already stared at for years. Webb has shown us that hidden worlds exist even in the most watched places in the sky. If one can hide inside Beta Pictoris, another can hide almost anywhere. The next picture we take might show a face we have been looking for our whole history. So why should you care about a few faint dots of light in the dark? Because those dots are our best answer to the oldest question we have ever asked. Are we alone? Every planet we image, every ice cloud we find, every barcode fingerprint we read is one more piece of that answer. The universe is packed with worlds, and we can finally see them. Somewhere out there might be a planet with an ocean, a sky, a sunrise, or something we do not yet have a name for, and it is waiting to be seen. Think about what it means to see a planet directly, with the light traveling to your eyes. The light from Beta Pictoris d left that world 63 years ago, back in 1963, when your grandparents were young. It crossed the void for more than half a century and arrived at a machine built by human hands floating in the dark. You are looking at a world as it existed in the past, a world your grandparents never knew was there. Every time Webb catches another world, we add another page to a family album of the universe, and our own solar system finally has neighbors with faces. Nobody knows what we will find next. It might be ice clouds on a super Jupiter. It might be a tilted planetary crime scene. It might be a small rocky world hiding behind a curtain of dust, waiting the way Beta Pictoris d waited. But one thing is certain. The sky is not empty, and it never was. We just needed a telescope sharp enough and brave enough to look past the glare. Now that we are looking, we are not going to stop. The next hidden world might be closer than anyone thinks. If this journey made you feel even a little bit of wonder, then help it reach more people. Subscribe to this channel so you are here for every new world we cover, and turn on notifications so you never miss the moment another planet is finally seen. In the comments, tell us this. If you could send one message to the people of any of these worlds, what would you say? And share this video with one person who loves looking up at the stars. One share can spark a curiosity that lasts a lifetime. Thank you for watching, and thank you for caring about what is out there. The universe is a big place, and it just became a little more familiar. See you among the stars.